Hi there. I'm going to be talking through this paper, Few-Shot Learning with Multilingual Language Models. So this is obviously going to be using some prompts to do this few-shot learning. And on top of that, it's focusing on having a language model that works for multiple languages. So this allows us to run a bunch of very interesting experiments, especially around using prompts in one language to perhaps use on an actual piece of text that is in another language, perhaps using that in a soft prompting way to generate a prompt that is few shot learned, etc., etc. And this paper is really focusing on this application and this general experimental design with the idea of improving under-resourced language capabilities with language models. As you can imagine, a lot of NLP research is not nearly as focused on certain languages as, say, English or Chinese or European languages. And this paper aims to sort of combat that. So they're working with 30 diverse languages, and they are going to do some upsampling in the pre-training of their model, which they call XGLM. So what they're showing here in this paper is what the data looks like after upsampling in this second graph here. So as you can see, yellow, we hardly have any representation from some of these languages, but after doing this upsampling procedure and pre or post sharding, that's going to change what percent of the data set is, say, in English as opposed to any other language. So you can see here Korean and Finnish, KO and FI are greatly increase in terms of their amount of representation in the data set. And we get a pretty neat graph on the top here in terms of the number of tokens in any one language for doing pre-training. So that is sort of piece one here, right? What they're showing here in this graph is they're grouping this by high resource language, medium resource, low resource, and extra low resource. And then looking at model parameters, they experiment with the size as shown here. In terms of the parameters and the size of the hidden states. What I think we really care about, though, is being able to say that, okay, yeah, guess what? As you get bigger models, model perplexity goes down, and as it turns out, we're still going to have higher perplexity for higher resource languages. I think this is kind of intuitive. So let's get to a little bit of how they are actually doing things. So they're going to look at zero-shot learning and a few-shot learning setup. They have the formal definitions of that here, and they're using a pretty standard language modeling objective. I won't get too much into the notation there. So they do talk a little bit about what they're actually doing here. So they assume high-quality prompts for a task are available in English, which makes sense. And we can have verbal or nonverbal prompts. So this is getting to some of the research from Lester and Li and Liang, who use nonverbal prompts, right? But yeah, they're oftentimes initializing with English. So the other sort of technique they're also looking at is using a translation model. I think they use the Google API for that to translate English prompts into other languages. There are some disadvantages here, but worth experimenting with. So yeah, they have two approaches: same language prompting, where we use prompts in the same language as example, and high resource prompting, where we use prompts in a high resource language, for example, English. I think these are some interesting questions because it makes sense that the embeddings of whatever language you're using are only as good as the amount of data that you have to train on. So I forgot where this is, but they have some held out tasks to look at the cross-task generalization. Oh, here we go. Yeah. So they have several held out tasks: XNLI, XCOPA, and XStory closed to perform model selection and analysis using dev sets. They apply the selected model options to the rest of the tasks and see how they do. So yeah, in terms of quality, they're looking at the average of per token log probabilities, ignoring the common prefix of different candidates as the scoring function for all multilingual tasks. They go into more detail in terms of what the task prompts are. They use a single new line as a separator for few-shot learning. So yeah, they're specifically designing the few-shot learning piece to be obtained with the in-language setting. So you're using prompts in the same language. and they are importantly averaging results across 5 runs, randomly sampling a different set of few-shot examples each time. This I think is good based on there's a paper called Flex where they specifically advocate for doing this because there are results that can be all over the place. So let me see if there's anything else here. Yeah, this is describing the data sets in more detail. Then we have the zero-shot and in-language few-shot learning performance as a function of model size here. So, oh, sorry. So let's just walk through that really quick. My apologies. So what we're seeing here is we have different shots. So it makes sense that as we get, say, into the brown here, we see better performance. Don't see that with XNLI necessarily. And then the other piece that we're also looking at is the model parameters. So I think that this more generally makes sense that we see this increasing as model parameters go up based on what we know about language models and their general performance. The piece that I think is interesting here are some of these like shifts that happen around like PAUSE-X, but when you look to see that this is only slightly better than random, I think that really goes to show you that we're not doing all that much better. It would be really nice if they scaled these axes in a way that showed similarity here, because yeah, guess what? Like, sure, your random baseline is 33%, but we're still only so much higher than that. The only case in which I think we see like some good performance in their models is an X-story close, right? Even then, that's not that impressive. Like 66% accuracy on a 50% baseline is like kind of meh. This is in looking at the zero shot and in language settings, and we don't see too much of a difference between zero shot and few shot settings. So some interesting stuff to begin with. They mentioned scaling laws, which I basically covered. I'm mostly just going to walk through some of the graph output because, yeah, that's what they're largely describing. So this is comparison on XNLI, which is one of those validation sets that they're using. It would be nice here if they were comparing like the parameters in a way that was more intuitive. So like this is 6.7 billion parameters, this is 6.7 billion, and then they're showing like, oh yeah, if we bump up the model to 7.5 billion parameters, it's better. Okay, let's look at the case when they're looking at these 6.7 billion parameters. In that case, these differences are either not quite there, especially for the high resource languages. Like if you're just comparing the lines here for that 4-shot setting and the English only setting for some of these, oftentimes that 4-shot GPT-3 setting is better. But if we're going to then translate some of those prompts into whatever their like same language would be, we do see some pretty notable improvements. Where I think that this paper really proves its worth is when we look at this in the lower resource languages. So I'm going to say this is Hindi, Swahili, and Urdu. Yeah, that is a huge difference in this translation setting. We don't see that quite as much though when we're just looking at English only for some of these low resource languages. I think that is a pretty interesting finding. Yeah, we'll be happy to talk more about this. They do a similar thing here. I'm not going to get into it because the trends are somewhat similar in terms of how relative performances look. Doesn't really help that they're just like, oh yeah, more parameters is better across the board. Like what we really care about are looking at these same like model size. How does their model compare to GPT-3, right? So more of that here. It's just looking at XCOPA, X-story close, and XNLI. So yeah, this is then looking at the same stuff with fine tuning. So 8-shot, 16-shot on the right here. So it's no surprise that there's some difference in performance here. And that again, they're saying that their larger model is going to be better than their base model that is reported here. Like 270 million parameters, you can't store as much language information. What a surprise. So what I think is relevant here, though, is doing this sort of comparisons between the 6.7 billion parameter models, right? So looking at the orange and purple lines, we do see some interesting trends. So like for WannaGrand, there's not as much of a difference, but for data sets like HelloSwag, for story close, I think you can say that those like 4% differences are more notable. I guess it's a bit closer, like 2% than 4%, but in some of these cases, that's not always going to be true in terms of mean accuracy. What I think is also interesting here is when looking at XGLM, the 7.5 billion parameter model, we're looking at a lower mean accuracy for some of these data sets. So this doesn't change all that much, I think, in terms of the number of few-shot samples as well, which is notable. You see that with story close, arc easy, but yeah, that doesn't give you this clear sense that just because you're using more few-shot samples is you're going to get to better performance. See here. So they also do some really interesting experiments here where they condition the candidate prompts of the test examples in the target language on the instantiated prompts of 32 labeled examples from a given source language. So can we build up prompts from other languages, basically, right? And so what they show here is kind of a mixed bag of results in terms of having, so this is going to be what they're taking the initial representation from, and then what they're putting the like prompt into. So the cross-lingual transfer, right? So their improvement over same language zero-shot performance for the evaluated language, and yeah, the first language and resource levels group refer to the source language, and the second refer to the target language. So source, target, and this prompt line. Let me highlight things somewhat more clear. Yeah, so source and then target. What I thought was interesting was looking at some of the cases when we're looking at things in the same language family. So this is Bulgarian, this is Russian. So we're saying that there's less of a decrease in performance if you're initializing your prompts in Russian as opposed to having them be in Bulgarian. And yeah, that is definitely an interesting result. But you know, across the board, I think that some of these are kind of random. We don't see quite as much value. In the case when we're looking at Thai, obviously there's this huge bump up in performance when using English, but you know, a lot of these cases we see using the same language is going to be better for these models. So yeah, I don't think that there are clear answers here. This is a somewhat similar like phenomena that they're looking for cross-lingual transfer. So the rows are languages used for training, columns show the evaluation languages used for evaluation, right? And so they're again doing this 32-shot improvement over 0-shot. So what that means then is, yeah, we're ideally hoping to gain some benefits by having, say, English as the encoding of our prompt, right? And we oftentimes see that is the case for English. For a number of these other languages, like Quechua, which is one of their extra low resource languages, they have like some groupings here which are very, very hard to see. Like anything above here is high resource. There's a decrease in performance. For X-story close, I just want to highlight one thing, which I thought was interesting. So they show for Hindi and Telugu. So these are two separate language families. They're both from the Indian subcontinent, but yeah, have no like similarity in terms of grammatical structure. I don't know about like vocabulary, but yeah, what this is showing is, yeah, if you like base your prompt in Hindi and then you are going to evaluate on Telugu, that there's an uptick in performance. And you know, looking at the rest of this, we don't see anything that is too notable here in terms of providing benefits. So yeah, I think there's no clear sign as to what is really helping here and what is necessarily going to improve. Ideally, you would see like some straight green or some straight like red. We see some of that for, say, like Swahili, where a lot of these source languages don't help all that much beyond Swahili. English helps out the most. I think for some of these low resource languages, the fact that you do see some like changes in performance is useful, but I mean, keep in mind that these are still negative for the most part. So not much to be said there. Yeah, they're just showing what the same language and the source language prompt is. Kind of looks funny, you know, you have all this, this is Vietnamese text. Yeah, and then they just have right, yes. The embedding for right, yes is going to be more semantically salient than something that they are trying to use in Vietnamese, is at least the idea, right? So they also run some knowledge probing experiments. Let me see what I say here. Yeah, so one of the claims that they're making here is that for the task of Swahili, they examined transfer from English and Arabic and showed that that exists. I thought that that was kind of a strong claim because I don't think that they showed it was all that much better, or that it was like just not as big of a serious improvement in terms of the model performance. So I think some of these claims are strong here. Let's see, what else do we have to say here? Yeah, so they surpassed GPT-3 in a number of language pairs for translation as well. I believe that's this Flores data set. And I don't think this is terribly surprising because they're integrating more languages into their pre-training, right? So the model has almost like an implicit sense of these languages when you're evaluating downstream. Not going to get into this too much. Their model is better. That is like very clearly the case. The other thing that I think is interesting here is they're like looking at these accuracy numbers. Like we're not doing all that much better in terms of overall performance. So I think it's hard to like really make the claim that this is a good model. It is a better model, like undoubtedly, but there's still a lot of room, I think, for improvement. I was sort of interested in why that would happen, but maybe for discussion. But yeah, this is the broader findings of the paper. I mentioned this in the reading group, how they also are looking at things like hate speech encoding, and they find that like when you try to do few shot learning on this, they're worse than zero shot, which indicates with the prefix described above, language models are not able to utilize examples, which I don't think is too surprising because we're doing pre-training on so much data that they have these biases that are more like deeply encoded, I guess. So let me see if there's anything else that I want to report. I don't think there's too much else here. They go through some related work that I think is super interesting. And some more limitations on their work, which is also super useful. Let me see if there's anything else I want to talk about here. Yeah, so I think that the most important thing that they report here in limitations is that the increasing number of languages will hurt performance on all training languages because you're just trying to do too much. I think of like someone trying to speak multiple languages at the same time. That just is not going to be quite as feasible. And there are certain biases that you learn. I would be interested to see what some ridiculous number of billion of parameters model like looks like on this, and whether you suffer less from the curse of multilinguality. Let's see what else. Yeah, they mentioned that they do not leverage bidirectional context, and that is obviously useful for a number of languages. Yeah, they talk about integrating like broader social values into this. But yeah, like at the end of the day, even if like your hate speech like identification metrics are not that great, it is important, like this paper, this model, for presenting a paradigm shift away from Anglo-centric view of the world of NLP, because we can integrate more foreign language data, more under-resourced data into these models, and that will have all sorts of downstream benefits, and I think provides huge value to NLP community that is, doesn't speak English or doesn't speak other popular languages. So thanks.